Hi, welcome back. So in the last video we have upgraded the battery capacity of my Powerwall, and today it's about the upgrade inside the electronics compartment. But before I want to show you what's on the table here, I just want to explain a little bit the challenge what comes when you have the idea to build a Powerwall. You know, putting up a few battery cells and an inverter, a charger, it's kind of easy. At the beginning you will always go and pick the low-hanging fruits. Everything what's easy, you know, you have excessive energy, you have sunlight, you want to store that energy in a battery. So let's say fetching a few more percent, bringing your PV system some electricity into the nighttime, and thus maybe increase your ratio of PV power at your property. That's gonna be easy, that's gonna be inexpensive. But if you want to push it beyond this initial step, and we are talking here of, in our case here, that we can only capture, let's say, 30 to 40% of our electrical need during the daytime. That is what you would usually use in a hotel resort. If you try to use as much energy you can during the daytime straight from your panels. But then all the rest, what you want to capture more, has to come from storage. So there's no other way around of this. And then, you know, there's the easy 10%, then it's getting harder. Probably there's already a lot of effort of storing another 20% of your daily needs, and then it's getting increasingly harder and harder. Or it's getting more and more expensive. You can solve every problem with money. I could go to the solar installer here, which is providing also battery storage, and I could pay $15,000 for a 5 kilowatt battery, or then 25 if I want to have more capacity. But in my case, we are here already today storing 25 kilowatt hours a day, and we are doing this for a fraction of that amount. At the moment I'm standing somewhere around, including this upgrade, I'm standing somewhere around $8,000, and that's probably it. So the objective of this upgrade is, of course, catching more of our PV excess energy. We are still exporting around 500 kilowatt hours every month, which goes for free for the utility here. So we're not getting anything for it. And of course, before giving it away for free, I want to catch and store more of my energy. And all of this has to be extremely cost effective. So this upgrade is designed the way that it will get much more value for the money which I'm putting in here, because I can already use an existing system here. I'm just expanding parts of it, and only the way that I'm using as much of the existing components which are built in there. So we have to, of course, watch all the limitations of those existing components, because the last thing I want to do is starting to replace all sorts of components where, of course, the wiring would be the easiest and cheapest. You just put bigger size of wires inside. But I don't want to replace the BMS if it's not necessary. I don't want to replace the contactor if it's not necessary, right? So upgrading means add more power, add more amperage. And increasing amperage would go towards limits of other components. Okay, so the second aspect is then, of course, if I put extra devices into the Powerwall, do we have the resources to support it? Do we have available excess energy, and where does it come from? And also, on the other side do we have the demand for another inverter, etc., right? And you have to understand, here I'm working in a three-phase grid. Properties who use three phases, you can use three phases in two ways. You can use three-phase devices. That would be high-powered devices like motors, etc. But this is usually not used as much if you're not if you don't have a workshop or anything, you will not have such devices here. Here on my property I don't have a single three-phase device. So when you have three phases, you have to see actually each of those phases individually. It is like you have three complete separate installations in your house. Every phase is one circuit, and on every phase you have certain appliances. And so our property, of course, is divided up into those three phases, and every bungalow, every guest room, then here in the main building it's kitchen, other parts, they are separated by phases, and on those phases we have appliances. And then on the other side I have three grid-tied solar arrays, which also each of those is tied to one specific phase. And this is also very individual. I have one quite big array on one phase because that one is designed to supply a lot of energy into those areas where we actually try to use a lot of energy during the normal operating hours of the resort. My second array is a smaller one on another phase, and then I have a third area which is very, very small on the third phase, right? So now the question is, if we add another charger, do we add it there where I already have two chargers on it? Can that array actually supply that excess energy I want to have? Or are we doing something else here? The same question for the inverter. If I add the inverter, do I put it onto the same phase, or do I need to put it somewhere else? Because that phase, for example, might not need the extra power then, right? And in the case of this upgrade, it's really like this. The third charger will actually take energy from the second biggest array. That other array has become the most exporting. And with the inverter, the same situation. With that phase where I'm pushing energy now with my 2000 watts inverter is already maxed out. So in seasons like this where air conditioning is not that much needed because it's not so hot, I could not even deplete the 6 kilowatt battery pack which I had before. So adding another capacity would not bring anything if I do not extend my demand, let's say. Right? And then we have at number 3, optimization. I have run that Powerwall now for 1.5 years, and I saw the limitations there, right? And what I saw is that actually during normal times and good weather situations like this, everything works perfectly. But let's say for the bad weather days, when you have cloudy skies, etc., what I saw is that array, even if it's a 7.5 kilowatt peak array, when you have a cloudy day, the output of that array will of course collapse, right? And it will collapse to around 1000 to 1200 watts. Even if I had 1200 watts going out to the grid, the smallest charger there is now at the moment 20 amps, did not activate because I told the charger, it's a 1000 watt charger, that it needs a little bit of a buffer to start using energy from there. So it was just not enough what the array was producing to start the charger, the first charger. You know, the primary objective here on the property is not to fill up the battery. It is to use as much PV power as possible. But of course, when you have excess available, you also want to use it and not push it out. And if it's then just not enough to start the charger and you are looking how the energy is just leaving the property, is a little bit sad. And this will be considered now in the upgrade. So what I'm going to show you in a moment is, first of all, what's here on the table, and second is then I will show you how the energy will be used from which of my PV arrays, and also inside of the main distribution board, which points from where I'm taking energy and where I'm pushing it back. And then we are going to the Powerwall, and we will just install this, and this should not take too long, and the Powerwall should then be able to use more energy, store more energy, and also discharge more energy. These are the new components for the electronics compartment. On the charging side we have an additional charger, and it's again a small vehicle charger. I decided to go again with such a device because they are extremely reliable and robust. They never fail. They don't even have a switch. You energize them with AC and you get DC out of it. This charger is set for a 16S lithium iron phosphate battery pack, and it will output constantly, in this case now 15 amps. So this will actually replace the 20 amp charger on the current setup, and will hopefully also then start to capture some excessive energy when the days are not as nice. Then we have there a 15 amps charger number 1 and a 25 amps charger number 2, and I have again 3 nice steps which are 15, 25 and 40 amps, which can be switched like that by the controller. The 20 amps charger, which is now there, will become charger number 3, and that one will take its energy from a different phase. Sometimes it might happen that one phase is used up all the energy, but the other phase has energy available. So after this upgrade, after this separation into 2 different phases by 3 chargers, it will be much more likely to capture extra energy which I could not capture till now. Okay, on the discharge side we have again a Sun GT-IL, but this time this is the 1000 watt version. Very small, very compact. Why 1000 watt? We don't need much more. I have set the 2000 watt inverter at the moment to discharge with maximum of 1500 watts. That's because of the heat here, so to have a safety buffer. And this one will be set to 750, 800 watts, somewhere there. And this one will push also into a different phase, so we will then have the chance to discharge much more energy out of the pack. We need DC breakers, AC breakers, another meter which will monitor the other phase then from charging. A bus terminals for the second phase which is involved here, and we also need a bigger cable for our inverter side. There I only have 6 square millimeters, which is just barely enough for the 33 amps which I'm drawing there with the first inverter, and together with this we will have 50 amps of draw, and that is too much for a 6 square millimeter, of course, and we will increase the wire diameter there. So this here is the array where I'm getting all my energy at the moment for the AC-Powerwall. In future it will be 15 and 25 amps, so 40 amps overall will draw about 2000 watts maximum then from this array. And then the remaining 20 amp charger from before will get its power now from here. So these are 15 solar panels here. We have around 5100 watts peak on this phase here, and yeah, there's always about 1000 watts which we can draw from here. That's no problem at all. So here, this is our main distribution board. At the moment the Powerwall is getting its energy from here, from phase number 3 at the garage, and we are pushing back the power onto phase number 2, which has these apartments here and also a part of the main building. And in future we are also taking here from solar shop number 1 and also pushing into the same, right? But this time I already prepared the wiring. This time we are taking and pushing back from the same place. You see here the CT, this is the CT from the new inverter. I leave it only on this one branch, so this is going to our coffee shop, another shop and the villa. There's enough demand there, because this CT can only be put on these smaller bus bars here. On the main bus bars here I would have to buy a new CT from, which is fitting over the big cables. I have already prepared another breaker. This phase will just be routed to the AC-Powerwall, and there will be terminals there where the inverter and the charger will just connect inside the Powerwall there. So this is now inside the Powerwall. I already mounted a board here, wooden board. There will be the charger here, our terminal on a DIN rail, and the breaker extra DC for the charger out. I already have the space here. The AC breaker for the charger and the meter I might either put here or I will add it in this area. So let's see if there's enough space there. For the second inverter I have prepared this place here. The cable is already coming from our MDB second inverter. It's a smaller sized one, will be here, and they will be together. Okay, so let's put all the new equipment inside, then we will just wire this up. The controller does have another relay available for the charger, so there's absolutely nothing to change. Even the software is already prepared to accommodate the new charger. The inverters will be just in parallel. There's no need for any software change. Our contactor is limited to 50 amps. That's why those two inverters will be set to not use more than 50 amps. The BMS is a 70 amps BMS. With our new charger configuration we will have a maximum of 60 amps going here through the system, and this is well inside the limitations of every other component. Okay, what I will put first is the charger. Just be sure when you're working on a place like this where there's a lot of energy around you, not to shorten out anything. Okay, so AC cable, DC cable, I'm just cutting those cables to the length I need and connecting it directly to terminals, so there will be no plugs or anything left on that. Okay, I'm continuing a little bit here, putting the DIN rail here for the terminals and probably also the meter. The breaker I can fit on the other side. Yeah, let's work a little bit and then I will show you how it looks like. Here inside the controller now the third charger on relay number 6. I have wired up the charging side now, and this is now, as you see, my charger 1. It gets the power still from there where it was before, where the 20 amp charger was connected, because it just took its place. This is now my charger 1, 15 amps, and it is putting out 16 amps. So it's working, and 1 amp more than expected. Okay, let's open the second one. This is now still my old charger 2. Charger 1 and 2 should be on. Charger 3 I did not activate yet. Charger 1 and 2 are now back in business. In the new configuration we have now a bit more than 40 amps together, as it should be. The cabling now for the new charger 3 is also done here at this place, but now I'm going to wire up the inverter. The inverter goes to the same bus, so I have to put the cable, and I already connected the limiter from outside, and then we are going to connect DC. Have to use the new wire. Once this is done, I will show you how it looks like. The AC is now also connected, all there. We have a terminal for neutral, we have a terminal for the phase, and the meter is already showing 0 or 100 watt hours. Brake is up, so I can now actually activate my third charger in the setup. So let's do that quickly. First I tell the controller my charger number 1 is now a 15 amp charger, number 2 25, okay, battery type LFP. I want to see average power. We need to invert a readout for the smart meter. So now we have charger 3. Yes, we want it on the phase number 1, and it is a 20 amp charger. Export limiter is no, and external watchdog timer yes. So all settings are done. The controller will reset, and then we should actually see a third charger being shown, and then also a secondary phase readout for available power. So let's wait the startup sequence. And here you can also already see we have the primary phase, which is phase 3 now, and the secondary we have also here the power, average 300 at the moment. You see, these are the smart meter readouts, and the phase number 1 is actually now importing, and phase 3 has export. So this is correct. We have available on phase number 3 but not on phase number 1. So we're gonna wait until we have some export there, and then we'll see if that charger will also start. And here you see the second inverter is already powered up by the AC side, but it is waiting for DC. Still we can actually change settings, and what I want to do is put the internal limiter, then I want to use the limiter mode. Set the power mode to 750 watts, so that should be all okay now. That should be all okay now. Restore this. So here the CT is showing minus 300 watts. Let's compare this. We have here showing minus 300. Yeah, so that is good. We are exporting, and here it's also showing export. So the CT is reading out correctly. So one more thing, and this is make new battery cable from our battery bus via the breaker to the contactor, inverter 1 and inverter 2, and we are going to use these new high power battery cables, and this time it's 10 square millimeter. And look what we have. We have 3 chargers running. Let's check how much amps. 59.2. Yep, everything running. Yeah, and it's done. The sun is in its perfect spot at the moment. We are right after midday, blue sky. All 3 chargers are running maximum speed. 58.4 amps are pushed into the battery now. The 2 inverters are ready. We're gonna check this at the evening. There should be no problems anyway. I already saw perfect switchovers, you know, when we started laundry on the old phase, where typically then one charger would switch off, the other charger now on the other phase was continuing to run. Yeah, it will be far easier now for the Powerwall to store more energy, also on not so nice days when it's cloudy. Then maybe at least the 15 amp charger will start. The sun is already setting, the controller has switched into inverter mode and has activated DC, and our 2 inverters are now operating. So they are both pushing at the moment around 240-50 watts, and you see the phase is nicely equalized. Okay, so all of this working perfectly. We can call it a day. This was the second part of the upgrade series. Everything about the power electronics, about the electronic compartment upgrade. This would actually now already work perfectly without any more changes. But there's still one more video to come, one more upgrade to do. Now everything is running on my controller version number 3, but there will be another upgrade also on the controller. It's not because it's necessary, but there will be some nice features on the version number 4, which will then also go much deeper into the details of the battery pack. But I don't want to tell too much at this point. Let's talk about it in the next video. So thank you for watching this one. Please comment as always, like the video, subscribe to the channel. Would be really helpful if more people subscribe. Thank you, and I see you next time.